You know how a self-driving car sees the road? Or how your smart thermostat just knows when you're on your way home? Well, we're going to pull back the curtain on the invisible tech behind all of that. It's a system that's literally blurring the lines between the digital and the real world.
But before we dive into the nitty-gritty, let's just zoom out for a second. Think about this. What if a computer program wasn't just stuck inside a box, crunching numbers? What if it could actually reach out, sense the world around it, and then do something about it intelligently, in real time? That's really the big idea we're exploring here.
And the answer to that what if is something called a cyber-physical system, or CPS for short. At its core, it's pretty simple. You've got the cyber parts, all the code, the algorithms, and they're directly controlling physical stuff. The best analogy, really, is a digital brain hooked up to a physical body. The brain thinks, it makes all the complex calls, and the body is out there in the real world actually doing the work.
All right, so how on earth do you build one of these things? It's not as simple as just plugging a laptop into a motor, right? Nope. It takes a totally new way of thinking, a whole new kind of blueprint.
And the biggest challenge, the absolute first hurdle for any designer, is building a bridge. You've got to connect two worlds that frankly speak completely different languages, and you have to get them to communicate so seamlessly that they act like a single entity. And this really shows you that core conflict. On one hand, you've got the cyber world. It's clean, it's logical. Everything follows the nice, neat rules of code. But then you have the physical world, which is, well, it's messy. It's governed by physics, by things like friction, heat, and just a totally unpredictable environment. The whole game in CPS design is getting these two polar opposites to dance together in perfect harmony.
So how do they pull that off? The secret sauce is a constant feedback loop. It's a three-step dance. Step 1, sense. You have sensors out there grabbing data from the real world, temperature, speed, whatever it is. Step 2, compute. The digital brain takes all that data, crunches the numbers, and figures out the best thing to do. And step 3, act. Little things called actuators, think motors or pumps, get the command and make it happen. In this sense, compute, act loop, it's not happening once a minute. We're talking continuously, sometimes thousands of times a second. That's how these systems can react in the blink of an eye.
Okay, so designing the system is one thing. But making sure it's not going to fail, making sure it's safe, that is a whole different beast. We're not just talking about regular testing here. This is more like a gauntlet, and the stakes couldn't be higher.
Think about it. When you test a normal app, you're in a nice, safe digital sandbox. Everything's predictable. But with a CPS, you are testing against reality, and reality is chaotic. How's the self-driving car going to handle a sudden downpour that completely hides the lane markings? How does a pacemaker react when a patient's heart does something totally unexpected? There's just no way to write code for every single crazy thing the real world can throw at you.
And that's what makes this so hard. In these systems, your margin for error is basically zero. A delay of a single millisecond in an airplane's flight system could be, well, catastrophic. So safety isn't just some feature on a checklist. It's the entire point. Engineers will run millions of hours of simulations, trying to find those weird edge cases. But even that's not enough. You've got to think about parts wearing out over time. And of course, the biggest wild card of all? Us. Humans. We're completely unpredictable.
So with all this complexity, you're probably thinking, who on earth actually builds these things? And it's definitely not some lone genius tinkering in a garage. No way. It takes a very, very special kind of team.
A team that can pull this off is a real mashup of different experts. Yeah, you need your software engineers to write the code, that's a given. But you also need control theory experts. These are the folks who are masters of those feedback loops we talked about. You need mechanical and electrical engineers who actually build the physical hardware. And this is so important. You need domain experts. The doctors who get how a pacemaker should work, or the pilots who know what an aircraft needs. They bring the real-world smarts that you'll never find in a textbook.
And this quote just nails it. To build that bridge between the cyber and physical worlds, your team has to speak every language of engineering. Each person is like a translator, bringing their own unique perspective to the table to solve this one massive, complex problem. It really is the ultimate team sport in engineering.
So let's bring it all home. As these systems get woven deeper and deeper into our lives, in our cars, our homes, even our bodies, they're just going to disappear. The tech will become so good, so reliable, it'll be invisible. It'll just work. And that leaves us with a really big question to chew on. As this digital brain and physical body become one, how is that going to fundamentally reshape, well, everything?